Having a look at our simple tree diagrams. It's already drawn the tree diagram for you. It's told you that the probability of rolling a number 6 on this bias dice is 1/5, and that is what's already been entered for you on your tree diagram. And you need to know that each tree, and this is our first tree, must add up to a total probability of 1. So therefore, not getting a 6 would be 4/5. So, because the dice doesn't change, these probabilities must be the exact same. So on our next tree diagram, we have 1/5 and 4/5, 1/5 and 4/5 again. Then we've completed part A. Part B wants you to work out the probability of rolling 2 6s. So here you need to select the route, and I always highlight this, that you're going to take in order to get the 2 6s. So there's only one way on this tree diagram that you can get 2 6s, and that is rolling a 6 first and rolling a 6 second. To go from tree to tree, we always multiply, so we would do 1/5 times by 1/5, and we would get our answer of 1/25. Our second question, again it's drawn the tree diagram for you. It's told you that the probability to the shops of getting a bus is 0.4. We remember that the tree must add up to 1, so therefore the probability that she walks must be 0.6. It then tells you the probability that she catches the bus from the shops. So our probability here from the shops is actually 0.7. Note it is not the same as the probability to the shops. But again, each tree adds up to 1, so therefore the probability of him walking must be 0.3, and this is just repeated below. So it's asked us to show the probability that Sue walks at least one way is 0.72. Well, she could get the bus to town and then walk home. That's at least one walk. She could walk to town and get the bus home. That's a second way of walking at least once. And finally, she could walk there and walk back. Again, that satisfies the condition that she's walked at least one way. So now we need to work out the 3 answers. So our first one was 0.4 times 0.3, and that's equal to 0.12. Our second way was 0.6 times 0.7, which is 0.42. And our final way was walking and walking, which was 0.6 times 0.3. So we then need to add our probabilities together because there are 3 different ways to achieve the same goal. Therefore, our probability is more likely to happen. So if we add these 3 answers together, we would get a total of 0.72. Okay, so in our third question, we've got a missing box. So again, we know that probabilities add up to 1. So if we add those 3 together, we get a total of 0.85. Take that away from 1, and you'll get your answer for having the label of a rat. Part B asks you for the probability that it's labelled cat or hamster. So we remember our OR probability means that we add them together and we would get 0.45. And then finally part C. They choose one card at random from their cards. What is the probability that they both choose a card labelled dog? Well, if we imagine this tree diagram for dog, we know that its probability is 0.4 and then 0.4 again. To go from tree to tree, we multiply, so we'd have to do 0.4 times 0.4, which is equal to 0.16. So our fourth question is very similar to the question 1. So I'm just going to fill in what we filled in before. Part B has changed slightly. So it wants to work out the probability of rolling exactly 1/6. That means you could roll a 6 to begin with and then not a 6. Or a second way is rolling not a 6 and then a 6. Both of those ways you have rolled only 1/6. So if we have a look at the first way, we multiply to go from tree to tree. So we do 1/5 times 4/5, which is equal to 4/25. And the second way, we've gone from 4/5 and we multiply that by 1/5, which again is equal to 4/25. We've got two different ways of achieving the same goal. So therefore, we need to add our probabilities together to get our final answer of 8/25. Our fifth question tells you that Kim rolls a dice and flips a coin. Calculate the probability that she gets a 2 and a head. So again, you could draw a tree diagram where you have your 6 different options coming off. However, we only need to fill in the probability of a 2 happening. Then, on our second one, we flip a coin, so we have either a head or a tail. The probability of getting a 2 on a dice, if it's a fair dice, would be 1/6. Probability of getting a head is 1/2. To go from tree to tree, using that route, we multiply. So it would be 1/6 times 1/2, which is equal to 1/12. Then wants you to work out the probability that she gets an even number and a tail. Well, there are 3 different ways of getting an even number and a tail. I'm not going to draw the full tree diagram because you don't need it for this question. So we know getting an even number is 1/6, and to get a tail would be 1/2. We have 3 different ways of doing that, so we need to multiply our probability by 3 to get our answer of 3/12, which is exactly the same as 1/4.